In the depths of our oceans, a mysterious phenomenon known as deep-sea gigantism unfolds. Creatures residing in the harsh, unforgiving conditions of the deep grow to astonishing sizes, adapting to survive against all odds. But what causes this remarkable growth? The answer lies in a combination of frigid temperatures, crushing pressure, and the scarcity of food resources. But there's more to this tale. Within these stable deep-sea habitats, species like the coelacanth and hagfish thrive, remaining unchanged for millions of years. What secrets do these evolutionarily distinct creatures hold? They are perfectly adapted to their surroundings, revealing a world where time almost stands still. As we delve deeper, we encounter hydrothermal vents, which harbor unique ecosystems that flourish in total darkness. Here, life relies not on sunlight, but on chemicals for survival. For instance, tube worms engage in a fascinating symbiotic relationship with bacteria, allowing them to extract essential nutrients from their extreme environment. Meanwhile, cold water corals thrive in these frigid depths, with some reaching heights over 115 feet. Can you imagine? Some of these corals have existed for over 8,000 years, silently witnessing the passage of time in a world few have ever seen. The Jemchug Canyon in the Bering Sea plunges over 8,500 feet deep, creating an underwater landscape that dwarfs even the Grand Canyon. What mysteries lie within those depths? The sheer scale and immensity of these underwater canyons leave us in awe and wonder. Yet, as explorers venture into these uncharted territories, they confront formidable challenges. The immense pressure and pitch darkness of the trench demand specialized equipment for survival. What does it take to explore such a hostile environment? On the surface, the Sentinelese people inhabit an isolated island, largely off-limits to outsiders. Estimates of their population range from 15 to a staggering 500 individuals. What unique culture and traditions reside within those few inhabitants, untouched by the outside world? Farther south, Antarctica presents another realm of extremes. Characterized by its brutal weather, over 99% of its surface is enshrined in ice, with thicknesses reaching up to 3 miles. Can any life endure such unrelenting conditions? In the shadows of these freezing waters, deep-sea creatures like the giant squid and vampire squid have mastered the art of survival, flourishing in the crushing darkness. Their extraordinary adaptations reveal secrets of life where few can exist. Among these adaptations, the black dragonfish wields its bioluminescent features to hunt and attract mates. How crucial is light in these dark depths where survival hangs in the balance? It's a reminder of the brilliance found even in the bleakest environments. Beneath the waves, zombie worms play a vital role as nature's recyclers, breaking down the bones of large marine animals. What lessons can we learn from their existence in such a harsh environment, where life continually finds a way to thrive? The tripod fish, with its unique ability to sense touch and vibration instead of sight, highlights the extreme adaptations necessary for life in total darkness. How does it manage to find food in such a treacherous world? Its fascinating feeding mechanism speaks to the wonders of evolution. Among these depths, a headless creature was discovered near Angola's coast, a startling revelation made possible by remote-operated vehicles. Scientists identified it as a cluster of siphonophores. What more lies beneath the surface, waiting to be uncovered? In the waters of Caesarea, a diver stumbled upon ancient Arabic gold coins, remarkably preserved by underwater conditions for millennia. What stories do these lost treasures tell? Remnants of a sunken ship caught in a violent storm. However, not all underwater discoveries are tied to the past. A mysterious structure resembling a spaceship was unearthed in the Baltic Sea, igniting speculation about its origins. Yet, the truth revealed it as a natural formation wrought by the relentless forces of erosion. But the mystery deepens. At the bottom of the trench, the pressure is an astounding 1,071 times greater than at the surface. How do explorers pursue knowledge in such a perilous environment? Specialized submersibles are essential to navigate this dark abyss safely. Even in the Mariana Trench, life adapts to extreme conditions. Bacteria thrive by feeding on organic molecules, similar to oil, forging a unique ecosystem influenced by limited food sources. What remarkable connections bind life in such isolation? The trench's depths were first unveiled by the HMS Challenger in 1875, but deeper explorations remained constrained by technological limitations. What secrets did those early expeditions unearth about this vast, uncharted territory? In this mysterious realm, creatures utilize chemicals like methane and sulfur for survival, while others hunt the weaker members of their community. This complex web of life illustrates the delicate balance of existence in environments so extreme. The megalodon, once the ocean's largest predator, is thought to have gone extinct, yet whispers of its theoretical survival in the trench spark endless speculation about its adaptability. Could it truly find shelter in these profound depths? To navigate these treacherous depths, there's a pressing need for specialized technology, such as syntactic foam, to withstand the immense pressure. Understanding these challenges becomes crucial for both future deep-sea explorations and ensuring human safety. Turning our gaze to the Champagne seeps off the Pacific Northwest coast, we encounter methane bubbles that intrigue scientists. What lies hidden within these enigmatic formations, captivating researchers with their mysterious behavior? In Iceland's Silfur Fissure, divers experience a rare thrill, touching two continents at once. Yet, the extreme cold brings significant risks, transforming this adventure into a chilling challenge. The Bermuda Triangle, with its notorious reputation, harbors a dark history of unexplained disappearances of ships and planes. Various theories abound, from natural phenomena to mythical explanations, keeping the mystery alive and tantalizing many. Then there's Baia, known as the Las Vegas of the Roman Empire, which now lies submerged off the Italian coast. Here, visitors can explore its well-preserved ruins through the thrill of scuba diving, uncovering a vibrant part of history lost to the depths. Pavlo-Petri, the oldest submerged town discovered, was a bustling port city during the Bronze Age. Artifacts dating back 5,500 years reveal an advanced civilization, leaving us to ponder the legacy of those who came before. Port Royal in Jamaica was once a bustling trade center, but its fortunes changed with a catastrophic earthquake in 1692. Now, it stands as an underwater archaeological park, preserving the eerie remnants of its 17th century past. As we unveil the submerged ruins, we discover taverns, storage rooms, and recreational buildings, each telling tales of a complex society rich in diverse activities and cultural practices. What lives did these structures once house? Advanced sonar technology played a pivotal role in uncovering the lost city, showcasing the remarkable intersection of modern science and underwater archaeology. What further discoveries await us beneath the waves? At this site, artifacts like pottery and tools ignite debates among scientists, but if verified, they could reshape our understanding of early human civilizations. What revelations could these findings bring to light? The Kronosaurus looms large in our imaginations, reaching lengths of approximately 30 feet and weighing over 20,000 pounds. Its massive size made it a dominant predator in the ocean, commanding respect and fear alike. With its teeth conically shaped rather than sharp, the Kronosaurus adapted for a powerful bite rather than tearing its prey. How did this unique adaptation enhance its ability to conquer hard-shelled animals? Its streamlined body and paddle-like limbs granted the Kronosaurus swift and efficient movement through water. How did these anatomical features contribute to its prowess as a hunter in the aquatic realm? However, the Kronosaurus faced fierce competition from larger marine reptiles known as mosasaurs. How did this rivalry shape the dynamics of prehistoric marine ecosystems and contribute to the Kronosaurus's decline? Imagining a world where the Kronosaurus still roams today raises intriguing questions. How would its presence impact sea tourism, altering popular activities like boating and surfing into dangerous endeavors? The ramifications of the Kronosaurus's existence would ripple across global sea trade, affecting human reliance on ocean resources and highlighting the intricate interconnectedness of marine life and human society. Lastly, one astonishing discovery revealed that soil from depths of about 2 miles mirrored the moon's composition, offering unprecedented insights into its formation. What does this revelation imply about the connection between Earth and its celestial companion? In addition, the presence of ancient rocks and fossilized remains suggested that life on Earth began 1.5 billion years earlier than scientists had previously believed. This finding sparked excitement within the scientific community about the history of our planet's biological evolution. Furthermore, researchers stumbled upon a massive underground water source, forming a significant ocean deep beneath immense pressure. What does this discovery mean for our understanding of Earth's water reserves and geological processes? The underground water source in the Cascades is expected to influence volcanic activity, creating steam and pressure that could potentially lead to explosive eruptions. How do these hidden forces shape the world above? Last but not least, the Cascade Range, formed by the Cascadia subduction zone, tells a unique geological history marked by volcanic activity and tectonic movements over millions of years. What stories do these mountains hold, shaped by the forces of nature? The distinction between the Western and High Cascades reveals varying geological features born of different formation ages and erosion levels. How do these differences influence the region's enchanting landscape and volcanic activity?